Find the domain of f of x equals the square root of x squared minus 6x plus 8. Here we don't have to worry about any denominators being equal to 0, but we do have to make sure that the radicand is greater than or equal to 0. In this case, that means x squared minus 6x plus 8 must be greater than or equal to 0. This is more complicated than we've seen in the other problems. However, we do know how to solve inequalities like these. This is a quadratic inequality, and we've done these before. We know that we have to solve the corresponding quadratic equation, and then we need to make a Sine chart to figure out what's happening in the intervals between these solutions. So let's start by solving the corresponding quadratic equation, x squared minus 6x plus 8 equals 0. To solve this, we need to factor the polynomial, and to do that, we need to find two numbers that have a product of 8 and a sum of negative 6. Those numbers are going to be negative 4 and negative 2. Then we can set each factor equal to 0. X minus 4 equals 0, or x minus 2 equals 0. And when we solve these, we end up with x equals 4 or x equals 2. We need to plot these on the number line, and we're going to be using closed circles because the inequality was greater than or equal to. So let's plot these on the number line. 0, 2, 4, 6, 8. We've got closed circles at 4 and 2. And then to figure out which intervals here are going to be a part of our solution, we have to make a Sine chart. So we'll take each of the factors that we have here, x minus 4 and x minus 2, and we'll figure out the signs for each of those, and that will allow us to figure out which intervals the expression x squared minus 6x plus 8 is positive or negative on. So let's look at x minus 4. X minus 4 is going to be positive so long as x is greater than 4, and otherwise it's going to be negative. For x minus 2, that's going to be positive whenever x is greater than 2 and negative otherwise. If you can't see this by looking at it, you can pick individual numbers to plug in on each interval and see if it works. For example, if we pick 3, 3 minus 4 is negative 1, but 3 minus 2 is positive 1. So the signs will be negative and positive. Regardless of how you figure these out, to find the sign of the answer, we have to multiply the signs of each factor. A negative times a negative is going to give us a positive. A negative times a positive will give us a negative, and a positive times a positive is a positive. Since we wanted to know where x squared minus 6x plus 8 is greater than or equal to 0, we look to the intervals where this expression is positive, and so we know we're going to end up shading in the outer intervals, the one on the right and the one on the left. This ends up giving us the intervals where x squared minus 6x plus 8 is greater than or equal to 0. Specifically, the interval from negative infinity to 2 union with the interval from 4 to positive infinity. Now, this represents where x squared minus 6x plus 8 is greater than or equal to 0. That means the radicand is greater than or equal to 0, and thus this is a representation of our domain. However, this is in interval notation, and we've been doing domains in set builder notation. So we want a way to express this in set builder notation. The way that we can do that is by saying that the domain is the set of numbers x such that, now this first inequality, this first interval is represented by x is less than or equal to 2. And then we're going to use the word or, and then write the other inequality, which is going to be x is greater than or equal to 4. The reason we're using the word or here is because it's impossible for x to be less than or equal to 2 and greater than or equal to 4 at the same time. We don't need a number that satisfies both of these at the same time. We're looking for numbers that either are less than or equal to 2 or are greater than or equal to 4. So this represents the domain of our function in set builder notation.